could do a SolidWorks design in like 5 minutes, and I'd be like, I'm just going to run downstairs and draw this up. Like if we need a bracket or something for around the house, I'm just going to draw this up real quick and send it to the printer. And then I do it and I go upstairs and then my family's like, you were gone for 2 hours. And I'm like, no, there's no way. There's no way.
That'll happen.
Yeah. But, I love SolidWorks, so I just keep using it.
You like SolidWorks?
No, I love.
That's crazy. I like SolidWorks too. Should we start the stream like this?
Oh, wow. Yeah, that looks good.
Good.
Where did you get that?
My basement.
Okay. That's nice. That's where I go for most of my various Halloween. Unless that's not Halloween. Is that just random?
No, I brought this out early for Thanksgiving.
Okay.
This is our cornucopia.
I like it. It. Are you holding it in front of your face or are you wearing it? Does it have a hole in the bottom?
It's whatever you want it to be, man.
Okay, cool.
Yeah.
Well, we're getting some feedback here in the chat. Sandy says he loves the shirt. I'm assuming he's talking about my shirt, the SolidWorks logo, displayed loud and proud here. And the engineer says, hi.
Hi, the
straight
engineer.
To the point. I like that, straight to the point.
Yeah, well, he is the engineer, so why mess around with fluff? Let's get to the point.
Engineering is all about coming up with the most efficient solution. So
that's right.
I appreciate that as well. Yeah,
good times.
Point. Yeah. How's everything else going for you? I'm adjusting my headphone cable here. You can't see me. Well, you're not looking. I'm adjusting my headphone cable.
You don't know that I can't see you.
It's true.
Can you hear my kid crying in the background?
No.
Oh, that's good. That's good.
No, I have filters for that actually. Being a fellow kid haver, so I can hold an entire conversation with a kid blaring in my ear, and depending on if the other party is also a kid haver, they either can keep up with me or they're like, "Are you serious? Or you're really just gonna plow through this like nothing's happening?" So, yeah, it's just part of it.
It's good times. Good times.
Yeah. So you mentioned that you like SolidWorks. Have you used SolidWorks for a while?
Yeah. I've been using SolidWorks for, what's funny is I've been using SolidWorks for vastly less time than most people that I know. It's been like 9 years.
Okay.
8 years.
Yep.
Yeah.
It's good. Yeah.
Woo!
SolidWorks is good. So what was the first version you used then? 2011?
2012. Okay. 2012, because it was just when it came out. It was like SP0 or SP1 of 2012. I took an essentials class on that, and 6 months later, I had my CSWE.
Okay.
Yeah.
Yes.
Fast tracked.
That was an epic chapter in the Toolbox Wars, but since you were living through it, it probably didn't feel like quite as epic. It was probably more.
I feel like
how it works.
Yeah.
Yeah.
The Toolbox Wars.
The Toolbox Wars. I mean, it's like, if you were a clone in the Clone Wars, you wouldn't really realize like what was going on with you, or if you were a rebel,
were just that heated about the toolbox all the time.
Right. If you were a rebel, you probably wouldn't refer to it as the Clone Wars, right? You would, you would just think that you're just trying to do your best to hang in there.
Yeah. This is all good stuff.
I like Star Wars lore. I think there's a lot to learn from Star Wars lore.
I agree. Yeah, me too.
Many lessons in there. But I think that they're probably, George Lucas, they say that he kind of like borrowed from some other stories, A Hero's Journey being the big one that people comment upon. But I mean, I think really everybody does that, right? You take some inspiration from other literary works and you kind of blend it in with your own experiences. And before you know it, you're sitting on a golden goose egg. Sitting there with a golden goose that just won't stop producing over 10, 20, 30 years of movies. I mean,
and they've all been perfect.
Yeah. I mean, let's go. I think we need to see 9 or 18 more, Let's go. I think there should be a reality TV show that's Star Wars themed, like maybe on the space station or something. I mean, I think the sky's the limit. We already got Lego Star Wars, so let's just keep going.
Good point.
So I think that does bring us up to 11 o'clock and the official start time. A little bit of bonus material for those of you who decided to tune in early, but I know that's not what you're here for. You're not here to learn about Star Wars and Star Wars lore. You're here to learn about how you can use tools found in SolidWorks, found in 3D Experience to create complex patterns with a lot more control, a lot more elegance, a lot less frustrations. And honestly, I mean, Andy, you know, you've been in this spot before where you try to create a complex pattern on a swoopy, lofty, wavy surface, and you're basically just praying the whole time that the customer doesn't need to change anything.
Right.
You know,
absolutely.
Like we can both, I'm sure, tell war stories about how we have plowed through a very complicated pattern design and all the different tools that we've used. You know, I've used everything from rib to, you know, creating millions of planes and basically just doing one instance at a time. But ultimately, at the end of the day, the real challenge or the real concern is, will the customer be changing this design? Because as soon as they change it, it's almost like you have to start over again.
Yeah, absolutely. And that is one of the biggest issue. It's like, how do you, like, you're trying to create a pattern that will like always update properly for all of the changes that you could possibly foresee, right? But you can't actually foresee every single change, right? So, and that's just the way that parametric modeling works, right? So what we're actually going to be talking about today is something that is not what we would call parametric modeling. It does end up generating parametric geometry, like NURB surfaces that can actually be used, you know, to send to the machinist or create a drawing with, or, you know, get finite measurements from. Like you can do all that, but how we set it up is actually this thing called computational design. So we'll get into that in a little bit and kind of show you like why, like all of the benefits, what all the benefits are, right?
Yeah. And I think that, you know, you said it perfectly. It's like we try in parametric design in SolidWorks, we try to anticipate what the customer is going to do. You know, we know that with this customer, the wall thickness is going to be between 60 thou and 90 thou. So as we're creating our design, we're going to test out that range and make sure that it works. But if you create a complex pattern and the customer comes to you and says, hey, instead of that being diamonds, you know, would you mind just quickly changing that into spheres? you're going to be like, yeah, no problem if you don't mind waiting another week. You know, I think that that's definitely something that, you know, if those of us who are, or those of the audience who are just tuning in now, can look forward to learning about. You know, it's not only about anticipating changes that, you know, the customer typically makes, but it's also about just having that flexibility to implement changes that you weren't expecting at all. Right. And then to be able to even maybe reuse some of that functionality, reuse some of that, you know, you have a pattern that you do for one customer, now a different customer comes to you and you're able just to take that same exact pattern and lay it onto totally different geometry. And, you know, in just a matter of minutes rather than a matter of days, have a product that you can then move on to the next phase of the design, you know, tooling design, rendering, whatever the next phase of the design is.
Yeah, right on.
So hopefully that's enough of an intro, a little bit of an intro, a little bit of a pregame show there. But I just want to say welcome to everyone. Thank you all so much for tuning in today. Today is October 28th. We got a few days left until Halloween. I'm very excited about it. But, you know, this seems like a perfect way to even get me more excited, which is to talk about SolidWorks in this live stream here on YouTube and talk about some of the tools that we have that actually go beyond what you can do just in SolidWorks, but ultimately give you a return that you can get back into SolidWorks. And that's what we're going to talk about today in the form of what's known as 3D Pattern Shape Creator. We're going to talk to you all about how you can create very complicated patterns, how you can wrap these complicated patterns around non-analytic geometry, and how you can do it using rules so that if that geometry were to update, you can quickly and easily replace the pattern, update the pattern, and still be able to move on with your designs. And so to talk about this topic today, we're joined by a very special guest, none other than my good friend, Andy Barnes. Andy, how are you doing today?
I'm doing great. How are you doing?
I'm doing great. Is it your first time on SolidWorks Live Design?
No, actually, way back in the beginning of the pandemic, I made a snowboard wax iron with SolidWorks surfacing live. That was fun.
Okay,
so one of my favorite times.
I got to catch a piece of that webinar, that live stream. I thought it was amazing. But for those of the audience out there who didn't get to see it, you're a surfacing guy.
I am. Yeah. I like to do SolidWorks surfacing. It's probably my favorite thing in the whole world. Yeah. And actually, are we sharing my screen right now?
We are not sharing your screen yet, but we certainly could. No problem.
I think this is a good segue to like jump in to show like kind of some stuff here that we're
while we're doing that, while the production team is changing that over, we are getting some great chat here. Steve says, Andy, is that a Voronoi shirt? How do you pronounce that word, Andy?
Voronoi.
Voronoi. Is that a Voronoi shirt?
Yeah.
And Eric loves...
No, it's if anything, I would call this a tessellated shirt because it's a bunch of triangles. But
okay.
Yeah.
And Eric loves your shirt. Alex says, greetings from Bavaria. What's up? I'm sorry, Axel. Axel says, greetings from Bavaria. What's up, Axel? Welcome, welcome. And Raju is here, says, hi, Toby, after a long time. Yep, hello. And none other than the myth, the man, the legend, Mike Sabocek is in the chat as well.
What?
Hi from Pennsylvania. So we got the whole crew out here, and you are now showing your screen. So I think this is a perfect time to maybe talk a little bit about how much you love surfacing. And, looks like part of this electric carving knife is missing.
It is. Yeah. So long time ago, we actually, like, if you've been watching SolidWorks stuff for a long time, you may remember this was the surfacing demo that we used to show a lot of the time, was this handle right here, right? It's pretty cool model, right? But it's kind of dated, right? And what we wanted to do is actually add a battery to this to have it be a wireless turkey carver, right? So you can plug it in, USB-C, charges battery, and now I don't have to have an extension cord to get to my, Thanksgiving dinner table, right? So we actually created a new handle, and one of the handles that we created was actually just created right inside of X-Shape. You've probably seen X-Shape by now, right? You can do push, pull, subdivisional modeling, really cool, and then you can bring it back into SolidWorks, right? But
so
a lot of people,
X-Shape is a tool that's available in SolidWorks.
It's a tool that's available on the 3D Experience platform. It's a browser-based tool. There is a connector to SolidWorks, so you can pass stuff to the platform and bring it back into SolidWorks pretty quickly and easily without having to worry about, like, did I overwrite my file, right? There's some basic data management that can happen without you even having to think about it. Just
okay,
pretty great.
So you got your tools in SolidWorks to create your kind of mechanical design, and then if you're a surfacing expert, you could certainly design a handle like that using surfacing. But a different tool would be to almost just have like a block of clay that you can push and pull. That's subdivisional modeling, right? Just
Absolutely.
Kind of push and pull nodes, push and pull surfaces, and then you can end up with a design like that. How long, if you're pretty good with X-Shape, how long do you think it would take you to do a handle like that?
I think like now that I know exactly how, like, everything to push and pull, you can make that thing in like 10-15 minutes.
Oh, wow.
But like right off the cuff, like not having anything, I think it took like, an hour or two, right? Trying to just like play around. But yeah,
thinking about like how long that would take me to do, I'm a pretty solid surfacing user in SolidWorks. I'd say that would probably take me, a day. Let's say it would take me, an 8-hour day to really push and pull and get it all to exactly the right shape. And you're saying you're able to bang out iterations. It
is like, But anyways, we're not here to talk about X-Shape. That's all good. I did want to point out that, like, hey, like, if you still want to use like traditional surface modeling, you absolutely can, right? So like you can use your SolidWorks models, whatever they be, if they're a swoopy surface model or, a blocky thing or whatever, you can absolutely use your SolidWorks model to put patterns on inside of 3D Pattern Shape Creator, which we'll get into in just a minute, and then bring them back down into SolidWorks.
Is that what you're showing here? This is one you did in SolidWorks?
Yep. This is regular old surface modeling, right? Okay. Like here's like, a bunch of actually, I don't think it's well, no, it is. It's just and here's like, a bunch of surfacing features in there, yada yada.
I see in the tree you've got solid body 1, so when you were finished, you turn this into a solid. We're ready to go.
Exactly. It's a solid body at this point. So if I go in and actually look at this part, we can see that the only thing I've done to it after I've surfaced it is I've added this split line to the top, right? So I've kind of cordoned off this area, and this is the area that I want to add a pattern to up inside of 3D Pattern Shape Creator. And there's a couple different ways that you can kind of like cordon off the areas that you want to pattern. You can absolutely identify all the areas right inside of SolidWorks. No problem. You can do that. But there's some other ways to do it too. So I think what I'm going to do is actually hop into the 3D Experience platform, right? So I am in a browser right now, right? I happen to be using a Chrome browser, but you could use any browser that you have, right? And what I'm going to do is open up this part that I've brought into the 3D Experience platform from SolidWorks, okay? And this is the geometry that came from SolidWorks. And then all I've done to it is I've actually just added some like offset surfaces. We can actually see that if I go back to this geometrical set here, this is actually a sub D body itself. So you could actually use X shape. And by the way, I'm in X shape right now. But you could actually use X shape to just kind of push and pull around, you know, whatever I want this area to be that I'm going to put a pattern on. And basically what that's doing is I'm doing a split line with that. And now I have just an offset at 0 or a copy surface, right, to identify the areas that I want to pattern, right? So now I have these surfaces that are areas that I want to pattern. Make sense?
Yep, absolutely. So you're going to put like some kind of a grip on there, some kind of like a knurl, you know, whatever pattern.
Right. So what I'm going to do now is I'm just going to take that and drag it over into X Generator Design, which is another app on the 3D Experience platform. Both of these are completely browser-based apps, okay?
Okay.
So I will hide this area right here, and then I am going to start creating a pattern on one of these two surfaces, okay? So the first thing that I might want to do is create an intersect with this surface, okay? So what I'm going to do is go down here to my intersection tool, and I'll select this plane, and I'll also select that surface. And now I've got this line, this curve that intersects all of that, right?
Yep.
No big deal.
With you so far.
So now what I could do is I could go in here and I could go find my divide curve by length tool. But what I'm actually going to do is pop open the graph. I like working with the graph, right? So now this is where things start to look a little bit different than they might look inside of, modeling with SolidWorks, right?
Sure.
So now what I have are these two nodes that got created, right? Now this is like an input node. And the first thing I'm going to do with that is I'm just going to rename this. We'll call it top surface. And there we go. And now that is Andy, intersecting with that plane.
I've seen you work this magic before. And I just wanted to ask you, maybe just for the sake of some of our audience members, would it be possible for you to actually apply a texture, apply a pattern right now so they can kind of see what the end result looks like before you go through and you actually build it up? Because I think that might help them kind of track what you're doing here.
No.
Okay.
I don't want to do that.
All right. Fair enough. I mean, we are on a limited time constraint, so I totally get it.
Yeah. I want to build it piece by piece. Just a simple one, just to like get an idea of how we could, how this is being built. So it doesn't just look like magic, right? Because this isn't just like out of the box, like, oh, well, I have this type of pattern and I put a button on it and it just like fills up the area, right? There's more to it than that, right? So what I want to do is I want to take this curve and divide it into a bunch of points, right?
Okay.
So I'm going to go divide curve, and now I'm going to add a number to that, right? And I'm going to say I want to divide the curve by 10 points. Now what I've done is I've taken that curve and I've divided it up equally, right? And we can do this with the segment tool. It's called the segment tool, right? Inside of SolidWorks, right? I can segment a line and get a bunch of points along a line. So now I've got that node. Now what I can do is add a plane, and I'm going to say offset point, plane offset point. And I'm going to say at every point, I want a plane that is perpendicular to, and I'm looking over in my graphics area, right? And I can those highlight, right? So I know that I want the YZ plane. And now I've got a plane that is parallel to that at every single point. So now I can say I want to divide that one, and I'm sorry. Now I can intersect, right? And I'll just leave that there because I can reuse that in just a minute. And I know I'm going to need to reference this top surface a bunch of times, right? So what I can do is just say I want that to be one of my favorites. And now when I come over here and I go to favorites, I can find top surface, right? And now rather than dividing this, which doesn't make any sense, I can divide this, right? So now I've got a bunch of points. Now I've got essentially like a grid of points along there, right? But what the problem is I have a number here, like 10, right? And then the distance between these points is much lower than the distance between those points. And what I want to get is like an evenly spaced amount. So what I could do is set up this thing called like a Voronoi and do this weird stuff. But I think what is cooler is I have to do this stuff all the time, right? So what I did is I actually created what we call a user operator and saved it inside of one of my libraries, right? So I'm going to say I want to open up the patterns library. And now down here in my geometry tab, I actually have a bunch of different patterns that I've created. And one of them is neighbor distance. Okay. So now I'm going to pull that out, and all I need to do is give that points, right? So now I can say I want to give it these points, and then what it does is it gives me the distance to the closest neighbor, okay? And I can always expand that out, and I can see, well, actually, it's all of this stuff in there, but I don't even need to see it, right? Like I'm just going to repeat all that, so I just say, okay, I'll just throw it in there, and now I got the distance to the closest neighbor. Now, the reason that I wanted that is actually so I could drive a different type of node. I'm going to say divide curve by length. Okay, so now I'm going to say I've got a bunch of these curves, but I'm going to divide them up by this distance. And this distance to the nearest spacing, right, is going to be approximately the distance between these. So now if I crank this up to, let's say 25, right? Now I've got essentially about, it's not exact, but about the same distance between this line and this line and this line and this line, right? So now they're sort of evenly spaced. Now what I could also do is I could actually turn this into a function, and we'll add the function editor. Right now, what we have here is a linear relationship of this one is just as far from this one, is just as far from this one, is just as far from this one. But if I add a function editor, I can actually control the spacing of this with a graph. So now they're kind of bunched up over at this end. Right?
Oh, wow. Yeah.
So now I can kind of say like, okay, like down here, there's a bunch more, and over here, there's less, right? So now I've got a whole bunch of points, right? And like in SolidWorks, like half the time, like when we're trying to create a crazy pattern, like it's just like, okay, I could create the seed all day, but then like, how do I tell it like all of these other places that I want it to end up, right? And I don't have like a ton of control over that, and it might not update necessarily well. You can see in here, I mean, like we can start playing around with this and get like wildly different, like kind of like gradient swooping differences between instances of the pattern, right? And I can do it very, very quickly and easily. Right?
Yeah, that's what I was thinking. It's like there's been times in the past where I've tried to do something like this on a curved surface, and so I'll end up creating the points to use like a point-driven pattern, but then they get the distance between them. How do you do it? Like a lot of times I would do a 3D sketch and make a bunch of lines and then make them all equal length, and that would give me kind of equal spacing, but it's very time consuming. I mean, you were able just to drop these points in here live for us in less than 10 minutes.
Absolutely. And I could even use this to also, I'm going to use it for another set right here. And I could say divide this by 2, and then I'm going to subtract 0.1 millimeters from it. And now I'm going to use these to create a sphere center point radius. So now at the center point of all of these, I have a radius that's being driven by the distance to the next one, right? And in no time at all. And what this is essentially the radius becomes the like this is okay, like distance to the closest neighbor divided by 2, subtract 0.1, and now I know that there's a minimum distance to the nearest neighbor of 0.1 millimeters.
Right.
And then I could use that for, a split command, a fill, all that good stuff, right? So like, here's an example of how quickly and easily you can create something that is able to update really easily, and like is just like the amount of changes that you would have to make inside of SolidWorks to go from that to that, right? I mean, it's just it's mind-boggling. Like you wouldn't be able to do it, right?
Yeah. Wow.
And I know there might be some people on the call that are like, okay, yeah, I mean that's cool and everything, and it's great that you got a little graph there, but like I could do that using equations, right? I could set up some sort of series of equations, and I'm like I've been on like SolidWorks tech support, and I am constantly amazed at like some of the stuff that our end users are able to create, like just mind-boggling stuff. Like I had no idea you could go this far. Like you're way past what I thought the limit was, right? So I'm sure that there are some users, maybe some users on the channel right now that are like, I could do this with equations. So I wanted to show you something that I don't think you could do with equations. Okay? So I'm going to do another input node, right? And this is how we get stuff into the graph that's like geometric stuff that was created, somewhere else. It was created somewhere other than X-generative design, right?
So like in this case, the input is referencing that surface.
That surface right there.
Okay,
yeah.
Got it.
So now what I'm going to do is I'm going to say surface sampling, and I'm going to just crank this number up to like 50, right? And now it just samples the surface and puts a bunch of points right on the surface, right?
Okay.
And they're kind of randomly placed, like they're sort of even-ishly placed, right? And then from that I can create this Voronoi, which we've actually already used, but we haven't really talked about like what it does exactly. So it's this special kind of shape that in math, if you like Google Voronoi and look at the Wikipedia, like you'll kind of like start to grasp like what's going on with it. But it's basically creating like it's like this, right? Like every point is creating not always a hexagon, but a lot of times like a hexagonal shape, depending upon where the neighbors are, right? The neighboring points, right? So I can actually use this, and I'm going to add a skin here, and then I'm going to say I want to generate faces with that, and then I'm going to hide this, and we can kind of see what has been created here. If I do a boundary, right?
Ooh.
I have this kind of crazy hexagonal pattern that was put on there, just by saying drop a bunch of points, right, and add a bunch of hexagons. Like, I mean, they're not all hexagons, but you get the point, right? Like that. If somebody showed me that and said like I want to create that in SolidWorks, I'd be like, I don't know how you're gonna do that, right? And like that, you could be like, okay, like I could get something close to it, right? And like you start like chugging away, but then it's like, okay, actually, I want to make it tighter. I want 100 of them, right? Now, there you go, boom, right? You got 100 points, right? Like,
wow.
You just can't. There's no way that you can do that with SolidWorks, right? So that's what I think really is like the power of this, right?
Well, what do you do with that Voronoi now? I mean, it's just split surfaces, right?
Yeah. So what I could do is, and this is a bit more time consuming. So I think I'll show it. I'm going to start dropping in some pre-created patterns, like you were mentioning earlier. I think now we have like a good understanding of like how you might build this stuff. So I just wanted to make sure that it didn't look like magic,
Yeah, it's interesting. I mean, it's very different from what we're used to in SolidWorks with that flow chart over on the right. It almost reminds me of like a graphical programming interface, like there's kind of elements of it that I've seen in Blender or in it reminds me when I was when my kids were a little bit younger, we would go through and do programming in Lego using the NXT models.
Exactly.
And it's like that kind of programmable, logical. What did you call it before? Computational?
Computational design is like the industry term for this, and I'm sure that there's a bunch of other terms. It's just the one that I've been told. So
you select your input, and then from your input you start going through and then establishing all the rules that are going to be applied to that input to generate geometry.
Yes. And I can also like another, like some of the really nice things is I can say I want to like put all of this in a box, and then I could say I want to organize it all, right? And it'll just like automatically like space everything out properly for me. Like it's really nice and organizational. And then I can do things like hide the entirety of it. And then I could even do things like, okay, I want to create a user operator from this, right? And that's how I could take that chunk and say I want to use this over and over again, right?
Right.
Cool.
Yeah, like if your company gets almost like a signature texture, then you might want to start using that over and over again on different products. And how do you do that?
Right. Cool. So I think it would be good to show like some of the other types of patterns that I can get on here really quickly. So I'm going to go ahead and just ditch all of those real quick. I shouldn't have got rid of my inputs, but that's okay. And I should actually show, but one of the other things that you can do is you can actually just like, if you want to share this with somebody, right, you can literally just take that whole graph and like share it out as like a text file, like a TXT. You can copy paste it like right inside of an email. I wouldn't suggest it, but you totally can. It works, It does look like a ton of gibberish, but you can do it. So I actually have like a whole bunch of stuff. For instance, I think this is pretty cool. Centered triangular grid with a tractor. So I'm actually just gonna open this up. You can see it looks like gibberish, right? Control A, Control C, and then I will just click inside of my graph area, and now it's gonna paste that entire graph inside of there. And then I just need some inputs. Right, so I just need to give it the main surface and the triangle size. So I'll say that's my main surface, and now it's going to build this. It's creating like a bounding box. It's grabbing the surface area of the bounding box. It's figuring out what the longest portion of it is and using that to be like the direction that it creates this triangular grid in. It's doing a bunch of math to center the triangular grid on the center point, right? And now finally it's actually like creating this attractor point, and then from that attractor point kind of moving the triangular grid, bulging it out in a certain direction, and then I'm offsetting all of the faces, right? There's basically like a face offset, a curve offset on every single face, and then I am extruding that, not extrude, but thickening. I'm thickening that surface, right? Normal to the other surface, right? Up by a certain amount, right? Pretty wild stuff.
Pretty darn wild. Yeah.
So now if I was to and then I can even put controllers on here, right? So for instance, maybe there's somebody who doesn't know how to set all this up, but they want to be able to play around with it, right? Well, here's actually like, okay, I could say the attractor displacement is larger and the attractor radius is smaller, and actually get this shape to update. So I'll say the attractor displacement is 7 and the radius of change. So that's going to be at its largest point, it's going to displace the point by 7 millimeters, and at its smallest point, it's going to displace it by like 0.1 millimeters or 0.01 or something like that, right? And that radius is how far away that change happens, right? So now I've made it small. I've made it push more, but for a smaller area, right? So this is actually like a different output than I would have gotten before, right? And this is actually like attractor displacement in the Y direction, right, is actually like, it shows like where this attractor would be. Well, what if I displace it by like 5 millimeters or we'll say 10 millimeters in the X direction? Now I'm going to get an attractor that's offset in like, it's no longer, it's going to go this way, whatever positive X is.
Oh, wow. Okay, I see what you're saying. It's no longer necessarily going to be symmetric.
Right.
It's going to be offset. Wow. Yeah, this is amazing. I mean, the chat's going crazy. PC says, beautiful, man. This is definitely something that, oh, wow. Yeah, look at that result.
Yeah. So and this is like the point of showing this part is the fact that like you don't like maybe you're not the person who's like the final decider for what this pattern is going to look like, right? But you could build this and then somebody else could play around with it, right? They can literally just play around with it. Like I can even flip the split orientation. Right now I'm extruding all of the inners, right? But if I flip it, then I can extrude all the outers, right? I must have an error somewhere, but that's okay. But like and you will get errors, and the other great thing about errors is if I have something where I have, 200 instances of something and I'm trying to do like a cut or a combine or something, right? SolidWorks, is going to say it errored. There's a general geometry problem. Right?
Yeah.
It's like, what does that mean? Right. And I have to like start going like, okay, where are all like the places where it may have failed? The great thing here is you literally get like a list output, right? And you'll have one that errors out, right? You can find those errors and you can go look at a specific point. And a lot of the stuff that ends up failing on this one is actually Jordan Tadich created this surfacing model. So I'll blame him. But it's actually this face should be curvature continuous right here, and it's not, right? So because of that, when you try to do like an offset line at like a diagonal across this, it's not tangent anymore, and then things start failing.
So yeah, really, if that was SolidWorks, we just wouldn't. The whole thing would just fail. You just wouldn't have a pattern.
You wouldn't know that. Yeah.
Right.
There would be no pattern.
Awesome. Yeah, because when you put that back into, I mean, even let's just say you were like, look, I don't know how to fix it in all these rules. These rules are confusing. You could put that back into SolidWorks, and then you could just fix those instances in SolidWorks or do whatever you do.
You can keep on moving. And a lot of times in here we go like, okay, I know like the edge cases are going to error out, and that's fine. They're just the edge cases, and that's not even important to me. And you can just move along with a thing that has an error in it, right? And like it's pretty sweet for that reason. So let me show you another one here. And
it's just so amazing because you at your company you could just have this library, like these are the different textures we use on different products, and whoever the wizard is, Andrew Barnes, you're the wizard.
I'm the wizard.
You go in and set up this library and then make everybody else at the company look great, because all they would need to do is grab lumpy diamond gradients and just add that back onto the model.
It might be my favorite name for something that I've ever come up with.
Let's see.
It also makes me think of lumpy gravy, which I like.
Okay.
Yeah. This is a Zappa reference. Yeah. Anyways, it's like, oh, he likes to eat lumpy gravy. That's kind of weird. So you notice I have like a whole bunch of different experiment controllers now. And basically I have like a bunch of different inputs, right? This one's the origin. I can do that. And then like, basically it's like, okay, what's your floor plane, right? All right. My floor plane is going to be the ZX plane, plane for lengthwise intersection. That's going to be my XY plane. And then the direction for the line is going to be this one. And so I know it is, wait, no, I don't. I don't know what it is. It's my YZ plane. And then I need to input my main surface, which is this one. And now should build. Is it building though? Sometimes I just need to like suppress and unsuppress something. Activate and deactivate something, which ends up that's like actually how you get a rebuild essentially.
Okay. Yeah, it's interesting. We're seeing the progress bar up there, but I'm not seeing any errors or anything, later in the logic tree on this one.
Right. Wonder if I put in, maybe this didn't. Oh, that's all it did. It didn't actually take the input. I thought it did, but it didn't. That's all it was. Yeah.
Yep.
Okay.
There we go. That's what we're expecting to see.
Yeah. So now this one is one of my favorites. what it's doing is it's actually going to create this diamond pattern and then have a gradient to the edge, right?
Okay.
So now this actually shows a lot better if I turn my edges off.
Oh, wow.
Right? And we can kind of see like I get this diamond pattern, and then I get a bunch of bumps. And basically what it's doing is it's saying the closer you are to this boundary, the closer that the bump is going to go up by one. The closer that there's a point in the middle of all these diamonds, and I'm basically doing a fill surface, a fill where the boundary is the diamond, and then there's a point, right? And closer to the edge, that point is basically on the surface, so it's like a flat piece, right? And then the farther away it gets, the closer it's going to be to my maximum lump height, right? So my max lump height right here is 0.5. What happens if I try and bump that up to like 2 millimeters, right? And now it'll, if it builds, right? Sometimes this one will fail because if you get that point far enough away, just like you would in SolidWorks, then your fill surface fails, right? So it's like it can be a gamble, but when it works, it's kind of fun. Yeah, woo!
Oh,
I got like a
yeah.
porcupine grip, right?
Like
so
that.
Now it's just saying like the biggest one is going to be 2 and the lowest one is 0.5, and then this actually plays with like the gradient itself. So right now it's like kind of pulled out, it's like going towards 0, right? But if I did this, now it's going to be much sharper on this end, and it won't actually get down to 0, right?
Okay.
And then I even have this one is actually it's changing like the layout of the diamonds. So if I were to do something like this, then we'll probably see smaller diamonds at one end and larger diamonds at the other end. And this is where things really start to fail, because then it's like I'm trying to do this like massive diamond on one end that like doesn't,
right.
and then like it's trying to like go like up at a certain distance and it doesn't. But we'll see if it works just for fun.
Right, but the point is that like if there was all of a sudden an uptick, across the country in the number of accidents that occur over Thanksgiving due to slippage of an electric turkey carver, this could be the conversations you and your team have. Like, what could we do to prevent those accidents?
Yeah.
Maybe if we added more grip to the handle of the electric turkey. Maybe if we made the diamonds a little sharper. And then in this case, what's happening in the middle there? Is that instances that are erroring?
That's instances that errored out, which is kind of, it's expected to like a certain extent when you start just grabbing stuff and like going wild with it. Yeah. But I would be willing to bet that if I put that down to back down to like a more manageable number, like 1 millimeter or 0.5 millimeters, those would probably all build just fine.
Okay.
Right? So
wow.
I did have one more that I wanted to show.
This is pretty incredible, Andy. I mean, this is again, I could imagine this being such a valuable tool. And I mean, in the end, is it difficult to take this geometry and get it back into SolidWorks?
No, and I'll show you that. I'll show you that in just a second, actually.
Oh, okay, great.
Yeah, totally. So this is the last one I want to show.
Steve says he wants to start having turkeys at the user group meetings instead of pizza. So
I agree. Actually, that would be great. The problem that can we talk real about turkey for a minute?
Let's go. The
thing about turkey is it's kind of dry, like it really isn't great unless you have like a ton of gravy on it, right?
Regular gravy or
lumpy gravy?
Lumpy gravy.
Or what kind of gravy? What were you thinking?
Yeah, that's what I was thinking. Lumpy gravy.
What's your feelings on cranberry sauce, man?
Man, very polarized topping in the world of Thanksgiving dinner table, for sure.
Yeah.
Some people love it. Some people think it tastes like chemical. I think I probably land in that latter category. Although as I get older, I think I've branched out. I've sampled different varieties, and I feel like I'm starting to understand what the appeal is.
So there you go, Toby.
Man, I got to say, if I had a turkey carver with that pattern on it, if I saw that in a store, I'd buy up the whole lot. That's a winner right there.
So, I mean, and like this is, it's fun to have like Toby's face, but we can totally like swap this out with like you could do a company logo, right? Or if you think about it, like this is doing is it's grabbing an image and then it's grabbing the pixels, it's dividing the image, slicing it up into pixels, and then it's saying like, the average color of this pixel is some gradient between black and white, right?
Oh,
that's the way I have this set up.
I thought what you were doing there, I thought you had like X, Y positions for each of those points, but it's automatically determining the location of those points based on the image gradient.
On the image, yeah,
that's amazing.
So, and like I'm doing some like math to like say like, okay, we're gonna place the image here, we're gonna scale it to this size, we're gonna slice it up by this much to give like this many pixels, and then it's taking the average color of each pixel, right, and determining the size of the sphere dependent upon the color of the pixel, right? And you can drive that too. So this happens to be black and white, but doesn't have to be. The other cool thing about this is if you're like, an artist, right, and you want to like, get this cool like pattern or shape or whatever, you can literally go into like a sketch tool, right? Or even just, marker and, picture, right? Like draw something on a piece of paper, take a picture, put it in here, and you can have that thing that you drew with your hand, right, represented by a really cool pattern like on your shape that has like this nice like cool gradient, right? I just think that's amazing.
Oh wow. Yeah, I didn't even think about it. So you could like, man, I'm just brainstorming here. You could like manufacture something that could be hung on a wall or presented at. Wow, yeah. I mean, you're blowing my mind a little bit here. And then like you could do it with holes. Could you use holes as part of the pattern?
Absolutely. Yeah. So actually, here we'll hop in here real quick. This is one of my mind blowers.
Whoa.
This actually came from XGG, brought back into SolidWorks. The image put on a bunch of sheet metal parts, and this actually works. I wouldn't say it goes lightning quick, but there are 40,000 holes in this SolidWorks part.
Wow.
40,000. I mean, like, there's no way that you do that with traditional SolidWorks, right? And right there, boom, I got a flat pattern that I can save to a DXF, send it directly to my laser cutter, right? Like, we're done. Right? Sick. So yeah, I think that is like a really cool use case for it, right? And if you look around, like a lot of buildings are actually using those for like building facades, right? They'll have like some sort of graphic on like sheet metal. It's basically just a bunch of sheet metal holes, and they're generating that using a tool like X Generative Design, right? So I mean, like, how would you do that if you were using parametric modeling? Like, you wouldn't, right? You could.
Yeah, you would just have to bring in the image and then sketch all those points. But then each hole size would be uniform. You'd have to also come up with a solution to make the holes different sizes.
Yeah, absolutely. Yeah.
Wow.
Yeah. So the other thing that we talked about.
You're blowing my mind here, Andy. You're completely blowing my mind.
The other thing is like, how do I get that back into SolidWorks?
Oh, right. Sure.
Right. So what we've done here is you can use the connector, right? Or you can export as a step file. So this other one was actually, I just want to show a couple different options, but this one is literally just an exported step file. So this one, you wouldn't even use the connector. I exported the step file. Step file can bring in things like sketch geometry. So I didn't even have to build solid geometry, right? I just created a bunch of circular sketches, right? And then brought that whole big sketch in and said, cut extrude, right? So you can do that. And then the other thing that you can do is you can bring in the surface geometry. And I don't have the example here. It's actually in a different file, and I screwed up and opened the wrong one. But you can bring in solid geometry. It recognizes the solid geometry. You can do a combine feature, and boom, you got a solid body, right? Combine, the pattern that I created here, like those Voronoi pads, right? And I just combine it with my original, and we're good. The other thing that you can do is if you created a surface, right? Like now, do you think I could thicken that surface? Probably not, right? No way. Come on. You know how like curvature continuity works, and like, it's just not happening. But I can just bring that surface body right back in, and all I've done is I did a delete face, right? I just deleted out the split line.
Okay,
right?
so the top face is gone now.
Yeah, the original one that I had in SolidWorks, gone.
Okay.
Right? This is my imported geometry that I brought in. right, from XGG, which comes in as a NURB surface, right? It's not coming in as tessellated geometry. You will find some other similar products to XGG that are actually bringing in, it's doing a translation. What you're looking at is like tessellated STL type geometry. And when you bring it into SolidWorks, it's doing a translation of that. And you inevitably end up with a bunch of gaps and things like that.
If you were using a different solution, you're saying.
Exactly.
Okay. But if you're Gesundheit.
Yeah. But if you bring this in, it's NURB surfaces, right? It's BREP geometry. It's already the stuff that you're using in SolidWorks. So I can literally just do a knit, right? And my knit surface command just works, right? I just throw in those surfaces, create solid, done. Right?
Oh, wow. Yeah. Now you're back in SolidWorks as an actual solid. So now you can, it's not just for rendering. You could use this to design tooling around this, for example.
Exactly. Tooling. I can create a drawing with this on it, like all of that good stuff. Right?
Wow.
Yeah. So I know it's 11:48 right now. We can go up to the top of the hour, right?
Absolutely. Yeah. Yeah. I'm looking at there hasn't really been any questions so much coming in. But whatever questions you guys have, feel free to put them in the chat. If I missed a question, just drop it in the chat there. I'm keeping an eye on it. But a lot of great comments. A lot of people saying hello. A lot of people saying that they are loving this. Steve is saying that you could actually take like your state map and turn it into a pattern and then like somehow manufacture it. So yeah, lots of good feedback here. But man, this model's pretty interesting. I haven't seen this one before.
So this is actually a sewing machine, and this was created by Mark Schneider here at SolidWorks. If you've been following SolidWorks for a while, you've probably heard Mark Schneider, right? You've probably heard his voice, probably seen him Model Mania. He's telling you how the model was built, right? He's the dude, right?
He's the man.
He created this model from scratch, right? And what's wild about it is I can take this and start rotating it. Everything moves. Like if you start looking at look at all the little cams everywhere and everything, like this really is like a testament to how far we've come with like assemblies and mates and stuff, right? It's just absolutely wild. It blows my mind. Like looking at this, like I can just rotate this one rod and everything else moves exactly how it does in a sewing machine, which I've looked at this thing. I've watched GIFs of it like on random places on the internet, and I still have no idea what's going on when the sewing machine like goes down and like I don't know, I would shove a piece of fabric through there and like it sews it together. I don't know how it happens. but there's a lot going on in the background. Now, absolute SolidWorks modeling beast. That's who Mark Schneider is. But, he's not really like surfacing isn't like his like, end all be all game, right?
Okay.
But it's
I like where this is going.
Yeah, I mean, so we got a case that goes around it. It's cool, whatever. I mean, like, it's a sewing machine, right? Yeah. So what we tried to do is
hold on a second. I just want to tell you something. Eric in the chat said Mark Schneider's model is so amazing.
It really is.
He wrote it SEW.
Oh,
it's so amazing.
Oh,
pretty clever. I had that. Huge shout out to Eric. You win for pun of the day on that one.
All right. So I'm gonna hop back into it's all good. That was perfect. So I'm gonna hop back into the platform, and what we're gonna do real quick is take a look at this other thing. So if I show the assembly here, and I'm gonna open this up. Won't save that. And
I think it's pretty cool how you're able to so quickly bounce from SolidWorks to 3D Experience to take advantage of some of these tools. There's just so much beyond what we can do in SolidWorks, and being able to quickly get in here to 3D Experience and leverage that geometry and then, leverage those tools as well. I just think it's so amazing.
Yeah. So here's my sewing machine. The whole thing was able to be brought in with a connector, right? And now it's all geometry that I can actually like utilize. Like I could start a sketch on this face if I wanted to, like all of that stuff, right? And what Jordan Tadich actually helped me with was he created like an X shape design here, which looks a little bit cooler. It's kind of he created it in like a couple hours. It could be better.
Okay.
But
I like
it's
it.
still pretty cool, you know? And what I did is I opened this up and just kind of created some areas that I wanted to add a pattern to, right? And we're going to say, 1152 here, right? What kind of patterns can I add to this thing in this amount of time, right?
Right.
So I'm going to hide this, right? And I've got basically like 3 areas, this region, this region, this region,
Okay.
right? And then what I'll do is I'll save this real quick, just so the bodies like show up hidden in the right way that I want them to.
Okay.
And then I'll open it back up in XGenerative Design. And I created another user operator, which you may have noticed, which is my lumpy gradient, right? Because if you think about my lumpy, my lumpy gradient model is basically built for like kind of like one surface. Mm-hmm. But now what happens if I want the pattern to go around like a loop? Right now it's a diamond pattern. It's got to meet up with itself on the other side. So it becomes like pretty tricky. So the first thing actually, and like the first thing I'll actually do is create this. So I can go to construct and I'll create a point. And actually I want to change the view to be not perspective. Just so I can visualize this thing a little bit better. The default in XGenerative Design is perspective. And what I like is the fact that you're able to just like, I can just like drag stuff around on a screen, right? And just go like, okay, that looks about where it's supposed to be, right? And now with that line selected, I can create a line and I want to say point and direction. And now it's looking for, it's referencing that point, but I can say, no, I want it to reference that point. And then I can take this line and, move it up here and say, I want it to go to about right there.
Okay.
And now I've got this line, right? Now I create, and like you can see, I did that all in the graphics area, right? So one of the things I wanted to also point out is the fact that like, hey, like you can do a lot of stuff in the graph, but you can also do a lot of stuff in the graphics area, right? So now it's actually created nodes for that. And then what I'm going to do is come down and add in my patterns library. And then over here, I've got looped, lumpy, diamond, gradient. You can actually add pictures for that too, which nice. Like create your own little icon. I need to do that. I haven't done it yet. So I'll say I want to grab this as my input surface. And here's my line. So now I just got main surface, line for lengthwise direction. And then if I made the line the right size, then this thing should just build in a relatively short period of time, considering like all that it's doing, right? I mean, like it's doing some nonsensical stuff in the background, right?
Yeah, I mean, it's just amazing to be able to have these, like I said before, as part of a library. I mean, it's incredible that you're able to generate those types of results. Wow, look at that. Just from essentially dragging and dropping and just using and reusing a library. That looks amazing. I mean, again, imagining trying to do that in SolidWorks. And it does meet up, you said? Like there's not a seam?
Right, there's no seam. It goes all the way around. And basically what I did is I took a grid of points and then I, imagine you have a rectangular grid and I say grab the first one here and then the second one from this grid and then the third one and then the fourth one and the fifth one, right? Now you take that grid, wrap it all the way around a cylinder, right? And now essentially you got a bunch of spirals, right? And then I just did the opposite direction. Now I've got a bunch of spirals in the opposite direction, right? So then from that, I can basically like slice the surface, right? Almost like a split face, right? To slice it up into a bunch of different diamond-shaped faces, right?
Yeah, and that idea of kind of having that blend, I mean, I'm sure everybody on the call right now is just imagining, like, how would I even do that in SolidWorks? Have them start out not as deep and then gradually get deeper and wider and larger. And then, of course, having the pattern all meet up with itself at the end. It's incredible, Andy. I mean, well done. Well done.
Thank you. Thank you. And like, just so we can see what's going on in there, right? If I click edit user operator, right? There's all my nodes, right?
Okay.
Now you can see this like spiral pattern that goes around, right? And this is, and all the individual points. I mean, even just saying like grab the geometric center of this face. Like, what?
Yeah.
How would you even do that, right? Like,
right.
yeah. So yeah, that's kind of like what's going on. And I did I did also want to show this real quick. I have like just some other examples of things that is this not gonna? I think it should update. It's probably because I have like the high quality graphics.
Yep.
Just some other stuff that I've created to kind of show you like, hey, like here's like some other stuff that's not just a pattern, but things that I have like built from scratch. Like this is like an actual weave.
Oh wow.
Right? And then it's on this X-shaped basket. So you can actually go into X-shape, move your model, and you can do this with SolidWorks too, right? You can move the surfaces in SolidWorks and that's going to update. And then you can grow and grab the individual, you can measure the individual length of all of those, right? And know exactly how much material and exactly what length each one should be ahead of time, right? This one's like kind of like I think it's like supposed to be like a makeup case or something, mm-hmm. But this is actually created from scratch in X Generative Design, right? Well, it's actually it's built on an X-shaped model, but then all of these surfaces are basically built out of, okay, like here's the point, and then I'm going to divide all these up, right? I put a bunch of points around the edge, divide curve, add lines to these points to divvy it up into surfaces, and then there's actually another curve that represents like how deep this dip gets in here. So you can move this point around, you can modify how deep that dip gets, right? And each one of these is individually different. So that's the challenge is like, could you create one of these in SolidWorks? Yeah, super simple, totally mm-hmm. easy, right? Could you create all of them in SolidWorks? Yeah, you could, but they're all different, right? There's no way to pattern that. They're all different.
Right, and on top of that, if this is the company you work for, you have many different size makeup cases as well.
Right.
Yeah.
So now you have the opportunity to just like slap that on there.
As I want you to keep showing these, I'm not cutting you off, but as we approach the top of the hour here, I just want to remind everybody, if you enjoyed this session, be sure to give us a 1 in the chat. Give Andy a 1 in the chat. Be sure to remember to like this session and subscribe. We're always putting out new content, and that's how you'll get notified about that new content. And let us know in the chat if you had any other questions, beyond dropping us a 1 to say great job to Andy. Let us know in the chat. We are going to stick around for just a couple extra minutes here for bonus content, but I do want to thank everybody for tuning in to Live Design today and remind you that we have new content coming out every single week, so be sure to just check out the SolidWorks YouTube channel and you'll see some more of that new content. Looks like the next Live Design is going to be John Milbury on November 18th. So if you want to learn a little bit more about the wonderful manufacturing tools that are available, be sure to come back and join us on that date. So with that, Andy, I want to see some more of this bonus content. This is pretty cool. This is what was that used for?
This is actually like the toe cap on like a shoe. Like you may have seen like certain shoes that are very popular for like skateboarding, right? Like that. This is like that toe cap that would go around the front of the shoe, and the shoe would kind of come up like that, right? And this is actually, this is actually the wrong version of it, but there's a version of it where I have basically the pattern. So like they're small over here, and then they get bigger and bigger and bigger over here, like a wave, which I think is pretty cool. And then this is obviously my favorite, but I just open that up and look at it sometimes.
We got to get that manufactured, and then we can hang it up at headquarters so everybody who comes in can see this like stainless steel sheet with a bunch of holes punched in it of my face. I think that'll be perfect.
Yeah, good.
Well, Andy,
yeah, so I think that's it. That's all I got.
Man, you nailed it. Your timing was perfect. I want to say thank you so much for being our guest today on SolidWorks Live Design. You were a wonderful guest, and you really opened our eyes to some of the other capabilities. You know, when you kind of hit the limit on what you can do with SolidWorks, just remember that there's probably a tool in 3D Experience that you can use where you can take your SolidWorks models, load them up into 3D Experience, and then take advantage of this whole array of additional tools and capabilities that we have in 3D Experience. And you just did a perfect job showing that to our SolidWorks customers out there. So thank you so much. Look forward to maybe doing another one of these with you in the future. Woo! And thank you so much to everybody who joined us today. And we will look forward to seeing you all in the next one.
Thanks, everyone.